A dead star in the constellation Lyra is spinning faster than it should be able to spin. Not slowing down, the way every known law of stellar physics demands it must. Faster, every single rotation tightening like a coiling spring with no explanation, no known mechanism, no precedent anywhere in the recorded history of radio astronomy. And the signal it is sending toward Earth arrives in two perfectly synchronized cycles, one every 841 seconds and one every 4,206 seconds, a ratio of exactly 1 to 5, mathematically perfect, choreographed like the ticking of a clock built by something that understood physics better than we do. Scientists at the National Radio Astronomy Observatory looked at that number and had one word for it: impossible. But that is not even the real story, because the object in Lyra is not alone. At the same moment, astronomers are trying to explain what they are calling a cosmic unicorn, an object so singular and so strange that its discoverer, Feng-Q Adam Dong of the NSF Green Bank Observatory, said plainly that you could call it a unicorn even among other unicorns. Something else was crossing through our solar system. Something that arrived from outside. A comet hurtling through interplanetary space at 210,000 kilometers per hour, born around a star that no longer exists, carrying inside it the chemistry of a world we have never seen and will never visit. And that comet, designated 3I Atlas, did something that made every comet scientist on the planet stop and stare. It grew a tail pointing the wrong direction, not away from the sun, the way every comet tail in every textbook on every shelf in every university teaches. Toward the sun, a sunward tail. A tail that contradicted the physics of solar wind pressure, that defied the geometry of how comets behave, that extended for 500,000 kilometers, a distance greater than the distance from the Earth to the Moon, in a direction that made scientists ask a question they had not asked about a comet in a generation. What is this thing, really? And then there is a third object, 1,500 light-years from Earth, in the constellation Monoceros, whose name, translated from the ancient Greek, means the unicorn. There is a black hole. A black hole so small, so quiet, so perfectly hidden in the gravitational shadow of its companion red giant star that astronomers almost missed it entirely. They call it the unicorn. It weighs only 3 times the mass of our sun, making it one of the smallest black holes ever confirmed. And its existence raised a question that sits unresolved in astrophysics to this day. How do you get a black hole that small? The universe is not supposed to make them that way. The math does not work. And yet there it is, pulling quietly on its dying companion, eating starlight, leaving nothing behind. 3 objects, 3 unicorns, each one impossible by the known rules, each one discovered in the space of a few years, each one forcing a rewrite of some foundational assumption about how dead stars, interstellar visitors, and the physics of space actually operate. And what the data actually shows is that these 3 discoveries are not isolated curiosities. They are windows into the same, deeper problem. The universe contains objects and mechanisms that our models of physics have not yet accounted for. Not in theory, not in speculation. In the documented, published, peer-reviewed record of what our best instruments have actually measured. And here is where this story becomes genuinely alarming. Because if we do not understand what these objects are, we cannot predict what they will do. Let us begin with the one that is spinning. CHIME J1634+44 sits roughly 4,500 light-years from Earth, which means the radio signals it is currently sending us left that object 4,500 years ago, when the pyramids of Giza were under construction and no human being had ever conceived of a telescope, a radio wave, or a neutron star. Those signals have been traveling through interstellar space at the speed of light across 42 quadrillion kilometers of nothing, and they arrived at the Canadian Hydrogen Intensity Mapping Experiment, CHIME, a radio telescope array in British Columbia that looks less like a telescope and more like a set of 4 enormous skateboarding half-pipes pointed at the sky. CHIME was not even designed to hunt for objects like this. It was built to map hydrogen in the universe. But its extraordinary sensitivity and its ability to monitor enormous swaths of sky simultaneously meant that when CHIME J1634+44 began pulsing, CHIME caught it, logged it, flagged it, and passed it to Dong and his team for follow-up. What followed was a campaign involving some of the most powerful radio observatories on the planet. The Green Bank Telescope in West Virginia with its 100-meter dish, the largest fully steerable radio telescope on Earth. The Very Large Array in New Mexico. 27 dish antennas arranged in a Y shape across the high desert, capable of resolving details smaller than the width of a human hair at a distance of 1,000 kilometers. The Low Frequency Array, LOFAR, a distributed network of antenna stations spread across the Netherlands and into 9 other European countries. And NASA's SWIFT satellite, looking for X-ray counterparts that might tell them whether the energy powering this object was thermal, magnetic, or something else entirely. Together, these instruments watched CHIME J1634+44 for months. They logged hundreds of individual pulse detections, and what they found defied every model they tried to apply. Long-period radio transients, the class of object CHIME J1634+44 belongs to, were only confirmed to exist in 2022. They are cosmic objects that emit bursts of radio waves on timescales of minutes to hours, far longer than ordinary pulsars, which spin and pulse in fractions of a second. Think of a standard pulsar as a lighthouse that flashes 1,000 times a minute. A long-period radio transient is a lighthouse that flashes once every 14 minutes. The question of what kind of object can maintain a coherent radio beam across such a slow rotation period is already deeply unsettling to astrophysicists, because the math suggests that most neutron stars rotating that slowly should have long since fallen below what is called the death line, the threshold at which they can no longer generate the electrical fields needed to emit radio waves at all. They should be silent, dark, gone, and yet they pulse. And yet CHIME J1634+44 not only pulses, but pulses in two distinct harmonics, one every 841 seconds, one every 4,206 seconds. And the ratio between those two numbers is exactly 5:1, not approximately. Exactly, as if the object knows how to count. But here is what elevates this from alarming to genuinely extraordinary. Every other known long-period radio transient in the universe is spinning down, losing rotational energy over time, the way a top slows and wobbles and eventually falls. That is what physics demands. That is what the conservation of angular momentum, applied to isolated spinning objects in space, requires. CHIME J1634+44 is spinning up. Its rotational period is shortening. It is accelerating. The team believes the most likely explanation involves a hidden companion, a second object in a tight binary orbit, gradually transferring angular momentum to the transient through gravitational interaction, or decaying through gravitational wave emission, pulling the two bodies closer together and spinning the system faster. But that explanation requires the existence of a companion that no instrument has yet detected. A dark companion, something there that we cannot see. Dong himself said it. We have a real mystery on our hands, and the mystery deepens when you consider what this object is made of. The two leading theories cannot agree. Dong's team at Greenbank believes the core of CHIME J1634+44 is a neutron star, the collapsed remnant of a massive star that exploded, compressing the mass of the sun into a sphere the size of a city, with a density so extreme that a single teaspoon of its material would weigh 1 billion tons on Earth. But a parallel research team at Astron, the Netherlands Institute for Radio Astronomy, analyzing the same object under its alternate designation ILT J163430+445010, believes it is a white dwarf, the dead core of a smaller star, less extreme in its density, less magnetic, operating by entirely different physics. Two teams, looking at the same object with the same data, cannot agree on what it fundamentally is. This is not a gap in knowledge that will be resolved by a better instrument. It reflects a deeper truth. We have discovered a category of object for which we do not yet have a complete theory. And now we come to what crossed through our solar system. On July 1st, 2025, the Asteroid Terrestrial Impact Last Alert System, ATLAS, discovered a faint moving object in the sky near the constellation Gemini. Within hours, astrometry began revealing the truth. The object's trajectory was hyperbolic. Not elliptical, not parabolic, but hyperbolic, a path that could only mean one thing. This object had not come from our solar system. It had come from somewhere else. The third interstellar object ever confirmed in recorded history, following Oumuamua in 2017 and 2I Borisov in 2019, and designated 3I Atlas. It was moving through interplanetary space at 58.6 kilometers per second. That is 210,000 kilometers per hour. Fast enough to cross the continental United States in less than half a second, and it was heading sunward. By July 21st, just 20 days after discovery, the Hubble Space Telescope turned toward 3I Atlas and captured an image that made the science teams go quiet. The object already showed a coma, a cloud of gas and dust surrounding its nucleus, meaning it was active, meaning it was a comet, not a rock. But the coma had a shape unlike any solar system comet at that distance from the sun, and extending from that coma, in the direction of the sun, toward the sun, not away from it, was a distinct, bright, elongated structure. An anti-tail, a sunward tail, at a heliocentric distance of 4 astronomical units, 4 times the distance from Earth to the Sun, still way out in the cold outer reaches of the solar system. 3I Atlas was already growing material that pointed the wrong way. A normal comet's tail is driven by solar wind pressure. The Sun constantly streams charged particles outward in all directions at 400 to 800 kilometers per second, and that wind pushes lighter particles in the comet's coma away from the Sun, creating the classic glowing tail that ancient civilizations watched with dread. An anti-tail, a A sunward tail can form in solar system comets as a brief optical illusion when Earth crosses a comet's orbital plane and the broad flat sheet of dust that trails behind the comet appears to project sunward due to perspective. But 3I Atlas's anti-tail was not a perspective effect. Harvard astronomer Avi Loeb and his colleague Eric Kito at the Harvard-Smithsonian Center for Astrophysics analyzed the Hubble data and concluded that the anti-tail was real, composed of large, relatively slow particles, likely grains of water ice ejected from the nucleus by carbon dioxide sublimation, large enough that solar radiation pressure could not easily push them away. They were moving sunward under their own momentum. The comet was throwing material in two directions simultaneously. It was behaving like nothing we had seen come through our solar system before. By December 14, 2025, as 3I Atlas approached its closest point to Earth, telescopes in Thailand and across Europe were tracking an anti-tail that extended 500,000 kilometers from the nucleus toward the Sun. 500,000 kilometers. That is larger than the distance from the Earth to the Moon. That distance, 384,400 kilometers, the gap that took the Apollo astronauts 3 days to cross, was smaller than the length of the tail of this interstellar visitor pointing back toward our Sun. To build a structure that large in the 45 days since the comet passed perihelion, the material in that anti-tail had to be moving sunward at a minimum of 130 meters per second, not being pushed sunward by the sun's light, moving sunward on its own, carrying its own momentum, going, in a sense, against the flow. This is not a theory. This is documented astronomy. The images exist. The measurements have been published. The trajectory is in the record. And here is where this story becomes genuinely alarming, because 3I Atlas's anti-tail raises a question that touches on something much larger than one unusual comet. It raises the question of what the interstellar medium, the space between stars, actually does to objects that travel through it for billions of years. The processed outer shell of 3I Atlas, the cosmic ray bombardment it had endured across the unimaginable distance it traveled, the chemistry that instruments detected in its coma, broadly similar to solar system comets in some ways, but with a CO2 richness that surprised researchers, all of this points to an object shaped by an environment we have never visited and cannot fully model. Its home star system may no longer exist. Astronomers at the University of Colorado calculated that 3I Atlas may be nearly 12 billion years old enough that the star it formed around lived and died before our own solar system was born. It is, in the most literal sense, a message from a dead world. And here is where the historical anchor falls, because the universe has already demonstrated what happens when interstellar chemistry and unexpected physics combine with the familiar violence of solar system dynamics. We know this. The geological record has already written it down. In 1994, astronomers watched fragments of comet Shoemaker-Levy 9, a comet torn apart by Jupiter's gravity into 21 distinct pieces, slam into the gas giant at 60 kilometers per second, each impact exploding with the force of hundreds of nuclear warheads. The largest impact created a dark scar in Jupiter's atmosphere larger than the entire Earth. We watched it happen in real time with every telescope on the planet and in orbit pointed at Jupiter, and what struck scientists most was not the violence. It was how surprised they had been. Shoemaker-Levy 9 had been in orbit around Jupiter for decades, probably since the late 1960s or early 1970s, breaking up gradually, and no one had noticed until Eugene and Carolyn Shoemaker and David Levy spotted it in March 1993, 1 year before impact. For decades it had been there, invisible. Now extend that logic to interstellar space. Objects moving at 58 kilometers per second and the speed of 3I Atlas do not appear in our sky with years of warning. 3I Atlas was discovered on July 1, 2025. Its closest approach to Earth was December 19, 2025. We had less than 6 months. And 3I Atlas was a comet, visible because it was active, because it was shedding gas and dust and growing that extraordinary anti-tail that caught our instruments' attention. What about the interstellar objects that are not active? What about the cold, dark, rocky ones? Oumuamua gave us 26 days of observation after discovery before it was already receding. The International Astronomical Union's own technical assessment has acknowledged that at the speed 3I Atlas was traveling, existing early warning systems for near-Earth objects would have had no time to respond if the trajectory had been different. The system is not designed for visitors from outside. It was not built for this. There are people who do not know any of this. There are people living their daily lives right now in cities and coastlines and river deltas who have never heard the name 3I Atlas, who have never been told that the third interstellar object in recorded history flew through our solar system and grew a tail that pointed at the sun and baffled every astronomer who looked at it. In Ahmedabad, India, a city of 8.6 million people living along the Sabarmati River, the night sky on December 19, 2025, was just the sky. Children were asleep. Markets were closed. And 268.9 million kilometers away, a comet from a star that no longer exists was making its closest pass to Earth, carrying inside its nucleus an estimated 33 billion tons of material, a number so large that if you converted it to every building ever constructed in human history, it would not come close. And no one on the ground felt anything. No tremor, no alarm, no visible change in the sky. The universe was doing something extraordinary, and we were the only ones watching. And even we barely understood what we were seeing. Now consider what this means against the backdrop of the spinning unicorn in Lyra. CHIME J1634+44 and 3I Atlas share something fundamental. They are both objects that are doing something they should not be doing according to our current models. One is spinning the wrong direction in time, accelerating when it should be coasting to stillness. The other is throwing material in the wrong direction, sunward when physics says it should be pushed outward. And in both cases, the explanation requires invoking something hidden, a dark companion, an unseen force, a mechanism we have not yet characterized. This is not coincidence. This is a signal from the universe that our inventory of physical processes is incomplete. Here is where the cosmic mystic speaks, because the data invites it. The solar wind that sculpts the tails of comets is not a passive medium. It is a physical force that originates in the sun's corona, varies with solar activity, and carries with it the magnetic field of our star reaching outward to the edge of the heliosphere, 120 astronomical units from the sun. The solar cycle, currently in solar cycle 25, nearing its peak maximum in 2025, with sunspot counts running ahead of earlier predictions, modulates that wind in ways that change how every active object in the solar system behaves. 3I saw Atlas entered our solar system at one of the most active periods of the current solar cycle, and the interaction between its outgassing chemistry and a more turbulent solar wind may have contributed to the unusual behavior of its tails. This is not speculation. It is the kind of connected systems thinking that solar physicists and comet researchers are actively modeling right now. The comet's tail was painted in part by our sun's mood, and our sun's mood is set by processes deep inside its magnetic interior that we can measure but not fully predict. And those same magnetic processes, the torsional oscillations inside the sun, the differential rotation of its plasma layers, the magnetic reconnection events that trigger solar flares, create the radiation environment that shapes the surfaces of interstellar objects. 3I Atlas's processed outer shell, the cosmic ray damage that had altered its chemistry across billions of years of interstellar travel, had been modified once more by the sun's ultraviolet radiation and solar wind particles during its passage through the inner solar system. The comet that arrived in July 2025 was not the same comet that left its home star system billions of years ago. The sun changed it, and what the sun changes, the sun can study, if we point the right instruments at it. Which is exactly what an international armada of spacecraft did. Europa Clipper, traveling to Jupiter's moon, was calculated to pass through the ion tail of 3I Atlas in late October 2025. The ESA's Hera spacecraft, en route to the asteroid Dimorphos, was predicted to be immersed in the ion tail from October 25th to November 1st. For the first time in history, operational spacecraft were deployed not just to observe an interstellar visitor, but to fly through it, to taste its chemistry directly, to measure its magnetic draping structure with instruments designed for different missions, but repurposed in real time for an encounter no mission planner had ever imagined they would need to plan for. The people who built those spacecraft did not know they would be doing this, and that quiet truth, that accidental intersection of human technology and cosmic arrival, is perhaps the most profound thing about 3I Atlas's visit. We were ready, barely, accidentally, barely, and we still do not fully know what we found. Now go back to the unicorn black hole in Monoceros. Go back to that compact object just 3 solar masses, hidden in the light of a red giant star 1/500 light-years away, pulling on its companion with a gravitational tug that shows up as a subtle distortion in the star's light curve. Tharindu Jayasinghe, a PhD student at Ohio State University who led its discovery, chose the name the Unicorn not just for its rarity but for its location, in the constellation of the Unicorn in the territory of Monoceros. The lowest confirmed black holes before this discovery typically hovered around 5 solar masses. Below 5, there was a gap, a mass range in which both neutron stars and black holes should theoretically exist, but very few examples had been found. Astrophysicists called it the mass gap. The Unicorn falls squarely inside it, which means either stellar evolution is capable of producing objects in a mass range we thought was nearly forbidden, or we do not understand stellar evolution as well as we thought. Both options are deeply unsettling. Both options are currently on the table. And here is the thread that connects all 3 unicorns. The thread that makes this not 3 separate stories, but one story about the same problem. In each case, The discovery came not because we were looking for something new, but because our instruments became sensitive enough to notice things that had always been there, that had always been happening, that had always been pulsing and spinning and pulling and throwing tails at the sun, and we had simply lacked the resolution to see them. CHIME was built to map hydrogen. It found a spinning impossible object. ATLAS was built to find near-Earth asteroids. It found a comet from another star system. The All-Sky Automated Survey was built to detect variable stars. It found evidence of a black hole eating a star from the inside. The universe does not announce its strangest contents. It hides them in plain sight and waits for us to build instruments good enough to notice, which raises the question that will sit with you after this video ends. Not a comfortable question. Not a question with a resolution. Because here's what the three unicorns share beyond their strangeness. They were all found recently. CHIME J1634+44 was announced in July 2025. 3I Atlas was discovered July 1st, 2025. The unicorn black hole was confirmed in 2021. All of them in the last 4 years of a civilization that has been pointing instruments at the sky for roughly 400 years. And seriously, systematically, sensitively for perhaps the last 100. The question is not whether there are more of them. There are almost certainly more. Dong himself said it. The discovery of CHIME J1634+44 expands the known population of long-period radio transients and suggests there may be many more such objects awaiting discovery. The question is, what else is out there that we have not yet built an instrument sensitive enough to see? What other objects are doing things they should not be doing? What other visitors are crossing through our solar system too cold and too dark and too fast for our current survey systems to catch? What other mass gap objects are pulling quietly on dying stars 1/500 light years away, distorting light curves so subtly that only a machine looking at millions of stars simultaneously would ever notice? Let us bring this home one more time because this matters for the people on the ground. Near the star-forming region NGC 2264, inside the constellation Monoceros, the unicorn, 2,700 light years from Earth, gas clouds are collapsing right now into new stars. Stars that will burn for billions of years and then die, some as white dwarfs, some as neutron stars, some as black holes, some in mass gaps we have not yet fully mapped. And they will form comet clouds around themselves the way our sun formed the Oort cloud, reservoirs of icy bodies at their edges, and some of those bodies will be ejected. Some of them are already in flight. There are interstellar comets crossing the galaxy right now, crossing the Milky Way, threading between star systems, some of them billions of years old, some of them carrying the chemistry of worlds that burned and died before our world existed. 3I Atlas may be nearly 12 billion years old. That is older than our solar system by over 3 billion years. It formed before the Earth existed. It traveled to us from a star that is dead. And when it grew that bizarre sunward tail and baffled every astronomer on the planet, it was carrying a question from a dead civilization's solar system to a living one, written in the language of anti-tails and ice grain velocities and carbon dioxide sublimation rates. A question we may not be equipped to fully read. The monitoring is in place. The telescopes are running. CHIME is watching the sky every night. ATLAS is scanning for fast movers. The Green Bank telescope is timing the pulses from CHIME J1634+44 with nanosecond precision, trying to catch the companion that nobody has seen. And the data from Europa Clipper's passage through 3I Atlas's ion tail is being analyzed right now in laboratories at JPL and at universities across the world. Detection is possible. The instruments are there. What is not possible, what the scientists are careful to say, and that careful language carries its own warning, is prediction. We cannot predict when the next interstellar object arrives. We cannot predict what it will do. We cannot predict whether the next one will be active enough to be seen before it matters, or cold and dark and fast and silent until it is already past. The question is not whether there are more unicorns in the sky. The question is whether the ones we have not yet found are more like a comet that grew a tail pointing the wrong way, strange and beautiful and ultimately harmless, or more like something we have no category for yet. Something that our instruments are only now becoming sensitive enough to notice. Something that has been out there for 12 billion years, moving through the dark, following a trajectory no equation in any textbook written before 2025 would have told you to watch for. And somewhere, 4,500 light years away in the constellation Lyra, a dead star that should be falling silent is still spinning faster, still accelerating, still sending its precisely choreographed radio pulses. One every 14 minutes, one every 70 minutes, a perfect ratio of 5-to-1. Out in all directions into the universe, including toward us, a message that has been traveling for 4,500 years, and that we only recently became smart enough to receive. We received it, we measured it, we documented it, and we still do not know what it means. That is where we are. That is what the universe is currently doing. That is what the data shows.